are still on tools to analyze economic problems. We've talked about the charts, the tables, graph. We've discussed what histogram is, pie chart, bar graph, simple bar chart, and a host of others. We've talked about frequency distribution. And so under this series of our frequency distribution, we are going to talk about other arithmetic or other tools to analyze arithmetic or economic problems. Today we will talk about the arithmetic mean. We'll see how it is used in a small group of distribution, in a large group of distribution, and how we can calculate it mathematically. But first, what is arithmetic mean? This is popularly referred to as mean. Sometimes they will not refer to it as arithmetic mean, but just mean. They'll tell you find the mean of this distribution. So, a mean is the average of a series of figures or values. Series of figures or values. It is obtained by dividing the sum of these figures by the total number of the figures or values. It is also the average of collection of observation. Average of a collection of observation. When I take some example, you are going to understand what I mean by this. It is arithmetic mean, and sometimes it is called mean. And you are given a series of numbers. This series of numbers, it tells you the average of this series of numbers you are given to work with. How do you get the average scores of a frequency given to you? That's me. So we are going to see mathematically how we can represent this, how we can work this out, how we can get our mean in a distribution. So let's see a few examples of how we can understand how we can calculate mean in a distribution. Now let's see how this formula is used. First, this is the formula for calculating arithmetic mean. X over sigma n all over n. What is x? Which is this? The x is the mean. The sigma represents a Greek letter denoting sum of. And so this that you see here represents a Greek write-up that is used to denote the sum of, calculated together of a sum of number. Then the EX, that's the sigma x, is the total. It is the total of the values of series of figures. That is the total of the values. I'm going to use this example to show you what it means. Then the n is the number of figures or elements in the distribution. Now this is an example. Calculate the mean for the scores of 8 students in an economics exams in the year 2010. The scores are 14, 18, 24, 16, 30, 12, 20, and 10. So when we talk about the number of figures of elements, it is just telling you some of these, you will just add 1, 2, 3, 4, 5, 6, 7, 8. There are 8 students. So it is 8 scores. That is what this n is just telling us. So now we want to talk about the total of the values of the series. How is it calculated? Now let's see the total of values. That is to say, sum this plus this plus this plus this plus this plus this plus this. That is the sum. That is the sum. So let us see this solution. The EX, which is the total of the values of the number in the series, is this. Remember we say 8 scores. I will have 1, 2, 3, 4, 5, 6, 7, 8. So we are going to sum this up 14 plus 18 plus 12 plus 16 plus 30 plus 12 plus 20 plus 10, which is the number of scores of the students. If we sum all these ones up, it's going to give us 144. That's our EX, sigma X. And remember, we told you that sigma X here is the total of the values of the series of figures. So, the E here denotes a Greek letter used in summing. So, it denotes summation. Why this EX is the summation of the total of the series, the number in the series. So we've come here to total it, and it's giving us 144. Remember, we said N is the number of figures or elements which we have calculated to be 8 students, which is 8. So to get my mean in this distribution, it is going to be the summation, which is mean is equals to summation of the number over the number. So that is addition of this number divided by the total number of students that took the exams, which we calculated. The total is 144. The number of students is 8, which is our N, and what we have as our mean, which is always the average of the distribution. The average scores that is gotten by the student is 8. So X here, which is the mean, is equals to 80. This is our answer for them. This is for a small distribution. The scores, we are just talking about 8 students. What if we have more students and we have to calculate the mean? How do we go about this? Let's see another example to show how we can calculate the mean of a more larger distribution. We have discussed how to calculate mean in a small distribution. A small number will have 8. It can be 5, 6, 7, 8, 9. That is a small number. But now we are going to talk about a more larger number. A number of students. First, the formula is going to change slightly. Remember in the other one, when we were calculating for our mean, we used just sigma X, which is the sum of the mean. But right now, it's going to change slightly because we are using a larger distribution. So we are going to use sigma Fx. The F will stand for the frequency. The X will stand for the mean, while the N will still stand for the number. So now let us take an example. Calculate the mean of the following set of numbers. How many are there? First, let us ascertain how many number of scores are we going to work with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So bear it in mind that the number of scores we are working with is 20. Now the next step you are going to take is look at the scores. What are the numbers you are going to work with? Then come out. If you remember our frequency distribution table, it has its own column. The number, the tally, and the counting, and the frequency they occur. That is where we'll carry our frequency distribution table that we had a class on in our last economics class. We'll bring in the knowledge here. So we are going to do a frequency distribution table for this because we are dealing with a more larger number of scores. So you just come to put in your tables, you tabulate. First is the number of scores. The next is your tally, then the next is your frequency. How many times did it happen? If you've not watched that class, go back and watch the class on our histogram and frequency distribution. So now I want to check what are the things that occur in this series. What is the smallest one? I will look. I will check. I will check and I will say, I guess it is 8. After 8, what is next? You check again. This is 8, this is 12, okay. This is 10. You look again. You do not find another figure lower than 10. You know 10 is the next number, you write it down. What is the next figure? It's going to be 12, you write it down. After 12, what again is the next smaller figure? You see? After 12, we don't have any other smaller figure. It's 16. You put down 16 in your numbers. Then you come again. What is the next smaller figure? You look 18. You have 24. Okay, 20, 24. You look again. Okay, that means it is 18. Then after 18, what is the next smaller figure? You look. This is 24. We have 20, 24, 24. Okay, it's 20. You put down your 20. Then you look again. What's the next figure? It's 24. You come. Then now we are going to tabulate. How many times did 8 occur? You look. You mark out 1. Put 1. You put again 2. How many times did 8 occur? You look again. There is no other 8 in that series. So you come here and put 1, 2. Remember, we are tallying. We are counting. Like we did in our kindergarten class. Now we'll come again, 10. You look again. How many times did 10 occur? You look again. You're looking for 10 and you say 10, okay? 1. You look for 10 again. You did not see any 10. You said, okay, 10 occurred just once. You come again, 12. Okay, how many times did 12 occur? You come again, you said, okay, 12 has occurred here, 1. Oh, 12 has occurred here, 2. You look again, you are still looking for 12. 12 have occurred here, you say 3. 12 have occurred here, you said 4. You look again, you said, okay, it's 4 times. You come to where 12 is, you said 1, 2, 3, 4. Remember we counted that it occurred 4 times. Now we come to 16. How many times did 16 occur? You come here, you said 1. You look again, is there any 16? You said, okay, 2. You're looking for 16, you said 3. Okay, I have 16 to be just 3. You come here and said 1, 2, 3. You come again. How many times did 18 occur? We are counting 18 now. You look here, we didn't see 18. Now we'll see 1. You come again, 18. We're still looking for 18. You come here, you said 2, and you said 3. And so you look, how many times did 18 occur? You said it's 3 times. You said 1, 2, 3. Okay, we are moving forward to how many times did 20 occur? You come here, 20. You do have 20 in the first series. No, 20. Okay, we said 1, 20. Oh, 20 just occurred once. We'll put 1. Only once you see 20. Then we'll go to another one, 24. You said, okay, 24 occurred 1, 2, 3, 4, 5. And we'll have 6. So we'll come here. Remember in our tallying, once we count 1, 2, 3, 4, you strike her, that's the 5th one, and we'll have the 6th one. So these are called 6 times. So now we'll come to our frequency. How do we get our frequency? Our frequency is gotten by this number of counters. So here, 8 is 2, 10 is 1, 12 is 4, 16 is 3, this is 3 again, 1, and this is 6, 3, 7, 10, 13, 14, 14 plus 6, 20. So when you sum it up, make sure this is 20. Because the number of distribution here, make sure the number of distribution you have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. When you sum the frequency, it must be equals to 20. The frequency must be equals to 20. So after you have summed it up to this extent, we'll see, let's go to the next level we will calculate with. After getting our table here, we are going straight to the calculation of how we can get our mean. Remember that our formula for this kind of distribution formula have slightly changed to sigma fx, that is the summation of frequency and number over number. So we are going to take, this is our f and this is our x. So we are going to use this times this, that is frequency times n, all over this number of 10. But for us to do this, we're going to see 2 times 8 will give us 16, 10 10 times 1 will give us 10. Let's see how we can do it in a more clearer way. We have 8. 8 times 2. 8 times 2, you bring it out. You bracket it. Same way you do for all the distribution in this place. 8, 10, 12, 16, 18, 20, 24. You times it by the number of frequency that they occur. After timesing it, you see that 8 times 2 will give us 16, which is eventually, if you want to make it faster, you can come here and just say fx. That's calculate this and this. You do it double ways. This times this will give us 16. This times 10 times 1 will give us 10. 12 times 4 will give us 12 times 4 will give us 48. 6 times 3 will still give us 48. 18 times 3 will give us 54. Then 20 times 1 will give us 20. And 24 times 6 will give us 144. And when we sum it up, we're going to have 340. Add up this. So you can do it this way. Times this to have your fx. Times this to this to have your fx. Or you can do it this way. Times this to this, bring it out. After you have added times them all, divided by 20, bring out what you've times. 16 plus 20 plus 10 times plus 48 plus 48 plus 54 plus 20 plus 144. That's all you have times out from here. Sum them up all over 20. When you sum them up, it's going to give you 340. When you divide it by 20, it's going to give you 70, which is the number. Same way here, this sigma fx, which is this, sigma fs is 340. All over n, which is our number. This is the number of times it has happened all over 20. It is still going to give us 17. So whichever way you want to do it, whether you are going to take it in this tabular form and get your fx, or you are taking it in this formula to get your fx. Whichever way you decide to do it, it is equally correct. Now let us see how you can tabulate for a group data and get your main group data and get your. Now let us take an example on a group of data or a more larger data. It says calculate the mean of the following marks scored by students in an economics exams. These are the scores. And how many students are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So there are 30 students in the class. So having ascertained that we have 30 students in the class, now let us see what are we going to do, because it is going to be for a group data. You will be told the intervals you will use. They will tell you use a scale of 10, 0 to 9, or the rest of them. Most times they will give you the score, the groups. They will give you this class boundary. So under this class boundary, we are using 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. This is our class boundary, or the score interval or groups. Now, how do you have your x? How do we get our x? For us to get our x, you are going to use 9. 0 plus 9 is 9. Divided by 2, we have 4.5. The same way you will do this, 10 plus 19. Whatever you have, divide it by 2. That is how you get your class boundary. Then, after you have it, you add this to this. You divide by 2 because we are looking for the mean. Remember, mean is average. So when you get this, is to be 9. You divide by 2, it will give us this. Same way you will do for all of them. Then, after you divide by 2 for whatever thing you have here. If you have this is 29. Divide by 2. you will have 14.5. This is 49. Divide by 2, you will have 24.5. This is 69. Divide by 2, you have 34.5. This is 89. Divide by 2, you have 44.5. This is 90. This is 90, 50, okay, 109. Divide by 2. What will you have? 54.5. Same way here, 60, which is 129. Divide by 2, you have 64.5. This is how you get your class mark. Now, having gotten our class mark, how do you tabulate? We'll come here. The interval. How many times did it occur between 0 to 9? You come here. 0 to 9. 8 falls under that. So you say 1. What again? Nothing is coming under 9. 6 falls under that. You say 2. Another 6 falls under that. You say 3. What again? Nothing will fall under here again apart from it's 3. And so you stick your number 3. So you have tabulated it to get your 3 because it happens 3 times between 0 and 9. Now we'll go to 10. Okay? So we're going to take from 10 to 19. 10 to 19. Anyone will have scribe off, we'll put it out. Where is our 6? We'll put it out. Our next 6, we'll put it out. Then the next one is between 10 to 19. 10 to 19. 16 is under that. 18 is under that. 12 is under that. 16 is under that, which is 4. 4, 5, 6, 7, 8, and 9. So we have 9. Remember our tabulation: 1, 2, 3, 4. The fifth one. This is 5, 6, 7, 8, 9. Same way you do for the other ones. We go to another class boundary between 20 and 29. When you look at it, between 20 and 29, we're having 6. 1, 2, 3, 4. This is the sixth one, and we'll have that. Then the next one, 30 to 39. The same way I tabulated for these, we're going to tabulate for the next one. Now after that, let's see the next point. So after we have taken our groups and we have gotten our mean, like I've showed you how to calculate your class mark, we tabulate the boundaries between 9 to 10, 10 to 19, 20 to 29. Look at the boundaries how it occurs. We have taken that. And we've seen that between 0 to 9, we have 3. Between 10 to 9, we have 9. Between 20 to 29, we have 6. 30 to 39, we have 5. 40 to 49, we have 4. 50 to 59, we have 2. Then 60 to 69, we just have 1. How do we get our fx? Now this is our scores. And this is our frequency. Like I told you in the previous class, you will times your mark over times your frequency. So we'll take 4.5 times 3 will give us this. 14.5 times 9 will give us 130. 24.5 times 6 will give us 147. 34.5 times 5 will give us 172.5. 44.5 times 4 will give us 178. 54.5 times 2 will give us 109.0. 64.5 times 1 will still give us 64.5. When you sum here up, make sure that this number we've counted is 30. So when you sum it up here, we are going to have 30. If you don't have 30, know that your tally is wrong. Then go back and retrace. But if here is 30, know that it is correct. You proceed. When you proceed, after you have time, sum it up. By the time I sum up everything here, I have 815. Now our formula comes into play. I told you there is a slight difference between the group frequency and just the small frequency that will have few number of students or few number of scores. In this one, our sigma, which is the summation denoted by the Greek word for sum of, fx, frequency of the mark or frequency of the class mark, over the number. which is this divided by this. So we have the fx to be 815 divided by 30, we have 27.2. So the mean, which is the average for the whole of this class boundary, is within the range of 27.2. So we have discussed mean in small number of scores that are less in number. We have talked about the group, and now we have talked about class intervals, class boundaries. So I know you can lay your hands on any economics problem that borders around mean, whether it's on a frequency distribution, class interval, class boundary, larger number, smaller number, you can be able to do it. So go over it again. One thing is to do over and over again, you get used to it. Lay your hands on past question and solve similar question like this. In our next class, we'll talk about mean. Mean. Thank you for being part of our class today.